Afternoon. Hope you all had a scrumptious lunch. We now head on to our third session for today. The theme of the session is skilling and scaling. I invite on stage the panelists, Mr. Vivek Pawar, founder, Sankalp Semiconductor. Mr. Naveen Bishnoi, AVP and Country Manager, Marvel India Private Limited. Dr. Arvind Shaligram, CEO, Science and Technology Park, SPPU. Mr. Samir Patel, CEMEX IITB. Mr. Karthik Shankaran, CEO, Deshpande Startups. I request Mr. Rajendra Chodankar, founder and CEO, RRP Electronics Limited, to felicitate the guests. I begin with the introduction of our moderator for today, Mr. Vivek Pawar, founder Sankalp Semiconductor, which he had developed into the world's largest independent analog semiconductor design service provider. He has a strong passion for mentoring startups and has invested in and mentored over 15 of them. He's currently the CEO of I4C, a not-for-profit organization that aims at enhancing the culture of innovation and employability among engineering students through the Vidya Leap program. He's also an advisor and trustee of the Deshpande Foundation. I invite Mr. Pawar to deliver his address.
Good evening, everybody. So, slides, sir. Okay. So I'll try to finish in fast because a lot of interaction time will be there. So, looking at skilling at scale, and if you have to look at that, the only one thing we need to learn from this whole thing is that last 20 years we are trying, but we are not done. So now we need to do something. We cannot do same thing and expect different results. So at the end of the session, we want to have some innovative ideas, creative ideas. So as a ISA, MCCIA together should kind of spearhead that so transformation will happen. Otherwise, we'll just talk and no action. So I think I'm expecting that to happen at the end. And fundamentally, we need to learn from success of few companies. I would say Karmik started training of the students from tier 3, tier 4 college students. So it just shows that you don't need kind of a tier 1 chip on the shoulder students to come to VLSI. Anybody can come as long as there is a proper training methodology. Sankalp learned from Karmik, I would say, and Samir will talk a lot about that. And Veda IIT in Hyderabad, it is also producing hundreds of VLSI engineers. So many of them are there successful. Can we actually do this for industry instead of company? And if industry has to do that, industry collaboration is required. And that's what I'm going to talk about mostly. Next slide. Okay, it's there. So my background, I think we've already talked TI, 15 plus years. Then the next three are same color that I played the role, basically Sankalp Semiconductor CEO, KLE Tech University board member, which was a private BUV college, and Deshpande Foundation, I was trustee and then CEO. So these all, I was in Hubli for last close to 16, 17 years. And then last year, I moved to Pune, where I'm working with I4C.in, which is a not-for-profit organization started by Anand Deshpande 10 years back. And now we are spearheading basically skilling at scale. And we have got into now 9 colleges totally this year, from 1 college last year. And we want to go at least 15 colleges in Maharashtra to make this model possible. So in that 40 years of my career, at Texas Instruments, there's no semiconductor companies. So we had to train new people on VLSI from the scratch. Sankalp Semiconductor, we went to Tier 2 city. So we had to train thousands of them. And then Deshpande Foundation, skilling. So I think skilling, I have experience, and that is my passion is there. So hopefully, I think we can make some action after this meeting. So what is the model? Sorry, I think I skipped one slide. So what are the 4 challenges? One is diverse skill. Unlike IT, where you teach Java programming or C programming or Python, you don't get job just because you have done some embedded C. You need to understand digital, you need to understand hardware, you need to understand integration of software, hardware, you need to understand coding and standards and protocols. So that's the first problem. And second problem is electronics is not preferred by students today. The top students want IT. Number 2 students want IT. Number 3 students want AIDS, IT. Number 4 wants kind of a data science. Only after they don't get anywhere IT, they pick up electronics or mechanical, thinking that they will do IT, some software, and get IT jobs. So they are not learning anything in the core job at all. So after 4 years, you are handed off with the electronics students who don't have passion for electronics, don't have knowledge for electronics, and you have to skill them. So we'll do a year-long process, and unless we go into the campuses, it will not work. Third problem is industry academia, no true partnership. Industry wants you to do high-end courses, and then you drop basic courses. So despite giving high-end courses, when interview happens, and industry tells you, oh, they don't have basic, so we are not selecting them. Supply side focus is much more. The 25 students who are sitting at home, don't have job, train them on skilling in embedded and place them in the company. We had already 2 companies saying that I need hundreds of people who are our customers, right? So demand side. We selected 500 students out of 1,000 through normal test. Out of 500, we came down to 400 and took interview of 400 students and selected only 4 students. That's a pathetic situation. And what we are checking finally, problem solving. 4 workers work for 4 days and complete 4 bridges. 8 workers in 8 days, how many bridges they will do? And they'll end up in 8 answer. We make small twist again, no answer. So I think that's a problem. So students have forgotten problem solving skills and self-learning skills. They learn pattern matching in CET. Pattern match the question, put the equation, get the answer. Any twist is there in the question, they can't solve it. So we are now went to 3rd year, now we are going. So what we did was, go to 3rd year, students who are interested in internship, take them for 2 months because companies will not give internship for 2 months now. They are used to supply of 5 months internship by final year. So 3rd year students don't get any internship. So we took them and we are giving them problem solving and self-learning during the 3rd year internship. And then we'll give the industry project to them. It will be reviewed by the industry expert. Out of that, 50% will drop out because they don't have that much of ability to work 8 hours a day. We require that anybody comes to us, 8 hours they have to work. And they don't have anything more than 2 hours kind of stamina. But that internship for 3rd year, challenge-based skilling, and mentoring for industry projects that we have started in around 12 colleges, shortlisted them, and actually 3 cities, Pune, Nanded, and Aurangabad. And next year we add the cities. Out of that, we believe when they come in 3rd year internship, by end of the year, some of them will get placed. They don't need to be skilled because they're already going through 2 hours every day and 2 months of summer. Remaining students who don't get the skilled jobs, then we'll do internship plus placement. So we do internship in the final semester. January, 8th semester is internship available for all colleges. And some of industry people don't know. This has become an industry itself. 20% students get internship. Remaining 80% to get the degree, they pay 10,000 rupees and get a certificate of internship because without that they will not get degree. They buy internship and not do internship and there's no learning. So that's what we're working on. Once that happens, we believe that this is still not scalable. Out of 100, we'll end up in getting 10, 15 ready for that. We'll have to go to 1st and 2nd and 3rd year. And that's the final project which will be We need to have embedded system challenge, competition created. But competitions are there, right? There are many competitions going on in India. Why is not that skilling? 99% of the students use Arduino kit. It was a boon, right? To break the fear of electronics. But it has become a bane now. You ask any good students who has done a good project, 5-6 projects in Arduino, how did you connect this interface to the CPU? 99% of the time you will hear answer through blue wire or red wire. They will not even talk about what interface is there because Arduino has made them transparent. What they have to do is they have learned amazing great way, understand the problem, put it on the internet, look at which software is available for the Arduino kit, buy the Arduino kit, load the software and make it work and get marks. That is happening today. And if industry understands it, I think we have opportunity now to change the competition. And for that, we need to use technology. And I think Karthik has been talking about technology in our panel, and he'll add that more, how it is going to help us. So we have actually going from DIY project happening in colleges today with no electronics learning. We have to go to bare metal board programming for students. And from there, we have to go actually AI-based proctoring because students know how to get marks by shortcuts. So whatever you do, they will find shortcuts to overcome that. So we have to start measuring with proctored through AI and through technology, students who actually do the project themselves, not copy. Only those are allowed for the competition, which is very aspirational. Students will do that and get it done. So whatever you measure, it will happen. So we have to start measuring students' learning and not outcome they produce, marks they produce, or project they produce. And that's the problem happening in India today. And we think we have a solution. We are working with a startup because as an NGO, not for profit, we don't have technology and capability. So we are partnered with a startup, but we require anybody who wants to do, they can do it. So we have a board now, which is kind of one of the company board, which is connected to the LMS system, AI-based LMS system. And students have to sit in front of the laptop or a phone and do it. If they use copy, they turn them, talk to somebody else while doing the challenges, it will be said as error. After 3 errors, it will be stopped and they will not be able to proceed. And that's what we want to do. And that will enable us to get students skilled by solving the challenges first. And only when they solve challenges, they are allowed to the competition. So when students come to the competition, these are not those students who are DIY projects who have copied the software, but students who actually solve the challenges and done their software programming themselves. And we start problems from year 1, year 2, year through. There'll be some kind of step-by-step change. So by the 3rd year, we believe that top 25% doesn't need skilling. They should be easily absorbed by the companies, and they should be doing the really industry projects in the final year. Remaining 20% will need skilling. Bottom percent, you can't do anything about it. Then we should let go. So that's the model we are looking at, and that's what we're running already in 5 colleges in Aurangabad, Nanded, and Pune, and to some extent in Solapur. This is going on very well. So finally, we should have a common vision. Skilling should be credit-based. It should not be outside the college campus, not as an optional. We should link their performance using the technology to get the marks in the class. Then only it will become scalable. It starts from the 1st year, not 3rd year or final year, because that's where students will get interested about it. It is technology-enabled, proctored to create project and problem-based learning at scale. If you don't proctor it, India's students are wonderful and talented to use the talent to get the result with the shortest shortcuts possible. The last one. So key takeaway for me would be, make electronics exciting. Today it is basically last option if I don't get software. For that, we tried in 2-3 colleges. I give a talk on basically jobs available in electronics, how it grows exponentially. Initially slow. Other jobs which are exponential in the beginning, they saturate and go down. And that has enabled at least 20% students want to go into core jobs, and that we are enabled. So I think as a ISA and MCCI industry, what we should do is, we should have every city a kind of annual workshops on jobs available in a cluster of colleges and deal as a cluster of colleges. Competition from 1st year for skilled students. In collaborative ecosystem, I think many companies have solved problem for themselves. learning from there, and can we work with the not-for-profit? I think Samir here is also working in not-for-profit for skilling. I'm working in not-for-profit, many other organizations there. All they got together and supported by industry associates and doing the course, working hard, and at the end you get the core job. Otherwise, they will not be interested. So collaboration is important. Technology will enable delivery. And finally, true industry-academia partnership, unless associations don't recognize colleges who are actually doing better skilling and getting good placement, and recognize teachers who are helping that, you will not find more of that breed. So increase the breed, you have to recognize. What you measure and recognize will increase. Currently, we are just getting the students, but not recognizing college or a faculty because we don't have proper measure. So we can create that measures of skilling and having skilling competition and recognizing students and colleges and professors. I'm sure it will start improving. So these are the things I talk about, and looking forward to very engaging discussion with the eminent panel here. Thank you.
Thank you, sir. Our next speaker for today is Mr. Naveen Bishnoi. He is the AVP and Country Manager, Marvel India Private Limited. In this role, he oversees all business operations to deliver and continue to grow and represents the company externally. As an engineering leader, he has led custom ASIC design for infrastructure domain. He has been an active member in EDA standards, conferences, and industry associations to enable semiconductor ecosystem development initiatives in India. Mr. Naveen Bishnoi.
Good afternoon. Good to be here. A few years back, I remember whenever me or a lot of our colleagues, if we are in an event and we saying, I am from Marvel Semiconductor, people used to ask me saying, what's Marvel and what's semiconductor? Thankfully, that question isn't asked anymore. All of us know semiconductor for multiple reasons because everyone is talking about it. And in that context, Marvel has been playing a key role. So we have seen a lot of activities from Marvel, so people know that. We have a pretty big R&D center here in Pune, and contributing to all those fabulous semiconductor projects that we talk about. But here to talk about from a skilling perspective, and I also say that I look at it from a perspective that we are all talking semiconductor. We also see India is in midst of it, and in many cases, it's the driving, I would say, force behind it. If you see, in India, there are two kind of developments actively happening. One is the whole physical infrastructure development that we see around in all the smart cities and the ecosystems that's being developed. Today morning, I saw the new Pune airport terminal that got started. I would say brilliant. It looks brilliant from outside. And then similarly, we have the digital infrastructure being created for the huge pace of digitalization that's happening around us. And so in that decade that we are talking about for India, what is the role for skilling and why we need to scale that? And that's I'll share some thoughts from my side, and then we'll have a discussion later as well, right? Quickly to introduce, right, 1998, July this week is when I entered into semiconductor, actually. So being in this industry for 26 years, I see that there has been a lot of innovation, practice, learning about problem solving, precision, and many other things. And then as I saw today, right, we are all talking semiconductor. All of us, anywhere you go, and then you spend 5 minutes, and we'll talk about AI as a word there for sure. So I'll say in the era of AI, semiconductor is currently the driving force. And then if you see, it's going from a usual design ecosystem into an end-to-end ecosystem. It is also going from a individual chip into a systems scope. We are talking not just about doing an IP or a chip, but also about the end product. And then in the era of AI, then we say that AI will come and do some of the jobs. So we will go and start doing some other jobs, which is more complex, bigger, and faster for the next generation products that's needed. So in that context, scaling is a very important point, not for just the entry-level students or early professionals, but for everyone else who is in the industry to be able to keep up to date on that skills and be relevant on that. And this journey is being driven by what we call as a continuous learning. I have done many skills, I've acquired many skills and hence been able to do many jobs. I've also seen how the ecosystem has changed, which started from as if it's an electrical problem or a physics problem into a multidisciplinary, and then it's continuing that way as we move into the manufacturing and others domain. And then also the realization that a lot of time people put skilling in terms of technical skilling, but equally important to also have the life skills and the soft skills covered as part of that. Now, why semiconductor scale? And if you look at it, this is a traditional, I would say, value chain of semiconductor that you will see. I picked it up. This picture is there available on Google search if you do. And then if you look at it from the top left side is where what we call as the fabless or the design side. I think you all had it and then coming up. Right? Now, a lot of us in the ecosystem has been existing for 4 decades in the left side, which is the fabless design, the box that you see in the center, but it has also driven some of the, I would say, development that of transistors, simulate them, figure out the reliability and efficiency, and then say this product can go out. Similarly, if we have IP, so there have been contents like EDA, the IP, and then the design part of it. And similarly in the manufacturing, if you see, the initial building blocks are, the first one is the materials, the different kind of materials and then chemicals and then raw materials that we'll use. The second part of it is what packaging floor that's there. And then once you put all of that together is when you have the final product or a system companies which can take the design, which has gone through all these simulations and building blocks, have the right materials, wafers, and the equipments to finally manufacture and get the product out. So the skilling is no more about just an engineering job, which was primarily focused on electronics, electrical and computer architecture. It's going beyond into skills that is needed for the algorithms to create the best of the EDA and CAD algorithms. It is also about the skilled or semi-skilled operators that is needed when you have the manufacturing floor going on. So the skill is actually pretty diverse right now, and hence there's a need for many of them to be planned, right? Now, why do we need to scale? We can do what we not need to do. We have hundreds of universities. It's that specifically get talked about each that product out of India, which is maybe India use case and some of the places in other part of the world as well. Are we doing the active R&D here versus we are picking it up from what has already been found out? And then you see a lot of disparity comes in, the gap in skills that we already talked about, and then focus also being moved towards a lot of computer science, and give a data is like, you know, my nephew was sitting in the entrance of a big engineering college in South, and then he had 11 choices of computer science with AI, computer science with data structure, computer science with cyber security, and then the 12th choice was electronics for him, right? So there are a lot of those things that we need to discuss and fix as we do that, right? Now, if we have to do the skilling and also do it at a fast scale because of the number of opportunities or jobs that required, we do need to play a role. And I'm trying to put this saying, I am an industry, I do a lot of things, so I'll talk about it. But if I look at academia and the students or the professionals who are out there, I look at some of these things, and we'll talk about it, so I'll not read or talk all about this. We are talking about saying what happens in the academia, how can we make it more relevant, more up to date, more hands-on, and all of that. So we'll keep talking about that. We'll also talk to the professionals, saying is that be aware that it's a continuous learning. What you learn in the 4 years of a degree or a 3 years of a diploma or your master's or PhD will needs to be reskilled or upskilled as we move forward. And I give that example as saying, like, most of us are carrying a backpack, and then we learn a skill and then put it in our backpack, do some job, and while doing that we realize and then go learn another skills, put it in our backpack, and then start doing something more and more. So a lot of time skilling leads you to many other job, and what we call as not just vertical growth always, some of the horizontal growth to be able to explore different opportunities that are there in the ecosystem. Right, and in some of the programs that's already happening, which many of us are part of in some or the other way, there are diploma courses, there are degree courses that exist. If we just take an example of OSAT or ATMP, I think you will be hearing this term quite a lot. As part of PLI, we have already heard three, I would say, announcement about the OSATs and ATMP houses being in India. If they have 100 jobs that will be enabled in an OSAT house, 50% of them will be semi-skilled operators. Another 25% will be skilled operators. So 75% of the jobs there will be of the operators. And then we'll have the jobs and skills required to be able to do the management of those programs, be able to manage the tool, be able to do some design, and also what are some of the R&D or engineering that's required there. And then there are programs that have started coming up. There's dedicated program coming up in manufacturing technology, both at diploma level as well as degree level. I know there's a certification course ISC has launched, and then few of the other courses in Gujarat keep getting launched because a couple of OSATs are coming here, and then few other places as well. Some of the other programs continue, but there are a lot of other ways skilling has been happening, right? We talked about finishing schools. So there are a lot of institutes which is outside the academia, outside the industry, but somewhere in the middle to be able to convert a student from an academia into an industry relevant. That's another handoff. That's another 6 months, 9 months. The whole question could still remain for us is that can it be plugged into either academia or industry rather than as a separate 6 or 9 months in the student's life or their career. We have C2S program for the government, and then there are a lot of other association related programs, either for awareness, for skilling, and many others. So these programs exist, and we can talk about it as we move forward. Finally, I want to leave with some of the questions or ask from my side, and I've divided it into 3 parts. First, what does the academia, the faculty, and the institute should do? What should the students or the early professionals should do? And then finally, there are policymakers or administrators and others they should do, right? Academia, we talk about saying like having the right curriculum, which has the right labs included, industry relevant topics and all of that. We are also starting the journey for R&D. India Semiconductor Mission has an initiative not just on PLI, DLI policies, but actually creating an R&D ecosystem. And what we have done as part of that is to divide the whole semiconductor ecosystem that I showed there into 12 research areas. And each research areas have couple of institutes to participate along with couple of participating industries to define industry relevant problems, to be able to say what would be the technology need, and then go do the research, whether it's a next system architecture or the next material or devices or a computer algorithm to be able to simulate faster or something like that. We need to encourage a lot of open source use, and I'm saying not just about the open source boards and materials, but I'm saying can we actually commercialize or socialize the whole open source lab so that any students can pick it up and then be able to play with a real case design, do simulation, have an experience with what tape out feels like, and then what happens in a manufacturing, test, assembly, and packaging. One program that I run very specifically in Marvel is what we call as a faculty enrichment, where the faculty says that, hey, I want to ensure that I'm relevant with what you're doing. And they spend 4 weeks in my office. And that, as part of that, we together find out saying what are the gaps that they thought that they haven't been able to practice themselves. And we try to ensure that over those 4 weeks, the faculty gets to practice that and then be able to go and teach that, as well as ensure the next generation of students do that. It's a very important part of scaling because as an engineer or as an industry, there's a limit of how many students or early professionals I can touch. I can probably go to maybe hundreds or something. But if we ensure that the faculties are up to date and are in part of this journey, then this can be scaled to 100x because of their influence being part of the academia system. Students, we keep saying is that while there has been a lot of quick push towards computer science and others, the science in semiconductor is pretty solid. We touch multidisciplinary, not just electrical and electronics, but computers, chemicals, metallurgy, mechanical, and all of that as part of the overall ecosystem. And most importantly, what we always say is that as long as you have those basics right, you are on the way to get into a career, and we'll ensure that the skilling keep on happening. And then finally, with the administration, which is representative bodies, or as associations or policymakers and others, for sure they can help ensure the infrastructure is up to date. It's available for the ecosystem to be able to use. What Vivek was saying is that we should start first year. Actually, some of us have started discussing saying we should do it in 11th and 12th. That's where they are making the decision of which branch they are taking, right? And so there is a thought going on that how do we reach out to the school students to ensure that semiconductor and electronics is understood, and there is a rush behind that, and not just on the other branches. And then finally, be able to do all of this either within the academia or in the industry to be able to keep scaling it, and then keep scaling it at the way we are asking about 80,000 or 100,000 jobs, or the new jobs or the new skills that will be needed. Thank you. We'll discuss further.
Thank you, sir, for an interesting talk. I now invite Dr. Arvind Sharigram, CEO, Science and Technology Park, SPPU. Let me introduce you, sir, first. Give me a minute. He has been a pioneering faculty member in the Department of Electronic Science at the Savitribai Phule Pune University, the first such department established in 1984 by the UGC and Department of Electronics, Government of India. He developed the first indigenous rapid thermal processing system and has been teaching postgraduate courses in ASIC and FPGA-based VLSI design using Cadence and Mentor tools. Dr. Shaligram.
So on the onset, let me thank the organizers. Sorry for the troubled throat, but let's go ahead. We are basically here to discuss about the semiconductor ecosystem and the requirement of human resource for the semiconductor ecosystem. So basically, we know that semiconductor ecosystem would require not just few engineers who are essentially skilled in particular analysis or particular method of thinking, but they are requirement of technicians. There is a requirement of thought leaders who would essentially contribute in the R&D process. There is a requirement of good managers who would operate the entire industrial operation. There is a whole variety of people who would be required for this. And how do we look at creating this kind of a system? Basically, we know that semiconductors, when we say, it is normally not, say, in early days, probably it could have been discrete devices, but now it is all talked about integrated circuits. And in fact, it is going beyond integrated circuits. So semiconductor IC design and manufacturing cycle, if we just try to understand, since morning it has been emphasized on our minds that yes, we start with systems. System specifications, architectural design, functional design for the ICs, logic design, if at all it is a logical IC, if it is analog IC, naturally, the circuit design, RF design also one can have. Then we have the circuit design. Subsequently, there is a physical design, which is very crucial and critical in the sense that even if you have things right in the logical, say, circuit and logical analysis, if you just say that it is perfectly functioning, it is quite likely, and in fact, most likely, that it is not going to function. So we have to really carry out a lot of working on that. We have to fine tune at that physical design stage, and subsequently then there is a fabrication. Fabrication is just single word, and we say that, oh, fabrication is fab. It's a fab lab. But one has to understand that the fab lab has so many processes and so many materials to handle with, and these all different processes, they have number of parameters to adjust. So these different parameters, how they can be tuned, how they can be adjusted. Say, for example, if we take an oxidation process, then in the oxidation process itself, we have the concentration of oxygen, what is the purity of oxygen that we are going to consider, how is the temperature maintained, what is the uniformity of temperature across the wafer, how the temperature control, how precise it is, and how it will be maintained when the wafer is inserted into the furnace. It's a quartz tube, and in that the wafer is inserted, or rather not just one wafer, but a boat of wafers, number of thousands of wafers maybe at a time they are inserted. And when they are inserted, during that process there are transients. There are going to be variations in temperature, because from outside to inside there are temperature variations, and these temperature variations are going to affect the oxidation process per se. I'm just referring to oxidation process because subsequently there are other processes, high temperature process like diffusion or annealing. These different processes, they also cause a lot of stresses on the wafers, and these wafers can get cracked, or there will be micro cracks developed at least. There will be straining, and these all different things, if you do not handle appropriately, then naturally the ICs, even though they are all properly designed, very well validated, they are not going to function. We have other processes, chemical processes, CMP process for the wafers for polishing. We have the etching process. We have the lithographic process. Lithographic process carried out with the help of some kind of lithographic materials, some resists, the exposures through the ultraviolet radiation or electron beam radiation. So we have all these variety of processes. And these all different processes, when they are carried out, at every stage there is likelihood of one or the other deviation, and that is going to cause trouble to the final end product. And in fact, there is a requirement of skilling in all these different aspects for everyone. It's not just the designer sitting in a specific place and trying to maybe scratch their heads and maybe argue with each other and decide that this is something what finally is going to work. But it is actually the people who have worked. Say, for example, a simple vacuum deposition system, if we just take, then we realize that the vacuum deposition system has to be operated in a certain manner. There has to be some roughing vacuum, there has to be some final vacuum, and this vacuum has to be appropriately brought, and you have to take measurements of the vacuum, what has been achieved. If you do not take the measurements properly, if the accuracy of the measurements is wrong, and if the instruments, they are not appropriately calibrated, then naturally the whole process, the entire batch will go waste. It's not only vacuum deposition, it is sputtering and variety of plasma processes. Variety of polymers are also being used these days in the entire manufacturing process of the integrated circuits. We have the processes of, say, metal deposition, not just one. In fact, earlier, probably the early electronics graduates, they have learned the device manufacturing as there is a metallization at the end. But it is not one metallization. Actually, there are as many as maybe 12 minimum metallization levels, multi-layer metallization that is done in the modern day ICs. And in fact, these multi-layer metallizations, their accuracy of placement, and then because of the inaccuracies in the placement, there is a likelihood that there will be sparks, there will be electrostatic discharge problem, and these are all different problems. They need to be properly handled, and for that purpose, there has to be skilling. There are different types of competencies required, especially if we just look at the integrated circuits that we talk about today. Then in the morning it was discussed that the integrated circuits which are being looked at, being manufactured maybe within the country, they definitely would not be the ICs which are really available today globally. Because those ones, they are anyway available. We have to develop something which is much more powerful than what are available at present, and that is going to take a lot of time. That is not easy, so easy. Whereas we have to develop some applications which are not handled by those ICs at present. So we have to look at different applications, especially in the communications domain, because that is somewhere we have a lot of progress. 5G, 6G is around the corner, and we know that there are a number of different applications in this particular domain, especially because these 5G, 6G are not just simple words. These are essentially coming with them the technologies which are associated with higher and higher frequencies. And higher frequencies, radio frequencies, they are very, very difficult to handle. So we have to have that kind of understanding. We have the computing requirements, computing including the AI, ML, that essentially gets into. We have the software requirements and we have the technology requirement. Technology per se is not necessarily only the technology of, say, having some kind of fab line, wafer fabrication going from end to end, but it is actually the technology which is giving the most efficient output. So we have the ICs manufactured and they have to function 100%. So in this, I am representing academia from the Savitribai Phule Pune University, and the Savitribai Phule Pune University has been involved in the skilling process of the semiconductors right from the word go. So to say, 1984 was the first fab established in the country. 1976 was the concept floated, and by the time it was established, SCL was established, it was 1984. So at that time itself, the Government of India, Department of Electronics then, they decided that there should be some trained young manpower available for this fab. As we are discussing the skilling at this stage, that time the thought process, the thought leaders, they thought that there should be a skilling available done appropriately through the conventional, traditional universities. And they selected one university among all in the country, that is Pune University. And the Department of Electronic Science at the university started with this intention that there will be trained young manpower in the domain of microelectronics. That was the combined mandate of the Department of Electronics and UGC. This program is functional since then and producing a trained young manpower, human resource, as a bridge between basic sciences, because we know that these days basic sciences have got significant importance in the sense that we have quantum mechanics, which is being looked at now for the future kind of computational technological advancements, that is quantum computing. We look at the quantum mechanics as things which are basically the source for spintronics. We have the electromagnetics, which is basis of any electronic, say, circuit or device, because electrons, they move under the influence of electric field, and the electric field having varying magnitude and frequency. So how that interaction happens, that essentially is understood by the electromagnetics. Solid state materials, because most of these circuits, integrated circuits, they are made out of solid materials. So solid state materials, solid state physics is one of the key elements. And these are all things which are coming from the basic sciences. They should be appropriately amalgamated with the application of these materials and devices for the end use. For that purpose, the MSc program that we are conducting at the university has been functional, and it is still continuing to progress. There are a number of people who are graduated from this. More than 100 professionals at present are working in different industries, including Intel, to work on fabless chip design companies. These are some of the companies. Then foundries, even there are people working in the foundries and ATMPs. So these different students, they are anyway giving us the feedback, and they are giving us the inputs like what should be the improvements further and so on, what is the nerve of the industry at present. Further, after 2000, the Department of Electronic Science on its own initiative has been conducting value-added training programs in association with some industry partners on VLSI design and embedded systems design, which also were well received. And still they are continuing. The batches are still on, and we have good amount of training conducted through these. These are basically, as I said, value-added programs in the sense that after graduation, this is a 6-month program, which is basically finishing school kind of program, which will make the students ready to work in the industries. Otherwise, normally it is said that the graduates of the Indian educational system, they are not employable. So probably we try to make them employable through this 6 months training program. There is a shift in required skills needed in the semiconductor industries. These professionals, they need to be proficient in using various industry standard tools. And these industry standard tools, they should be probably, one has to understand like at what level we are going to intervene. Say some of the simple tools I'm mentioning here, like SPICE, Supreme, then 2D device simulators like MinMOS, and various such level of tools where essentially students can carry out variety of trials and develop some kind of goal-oriented outcomes, goal-oriented circuits, so that they can essentially come out with the proper understanding of the solutions. They should also be familiar with, and that's what we have been following, tools like Cadence tools. We have Mentor also. So Cadence and Mentor graphic tools. These tools, they are exposed to the students, and the students are prepared for that. These of course, are one type of job, skill orientation for the students. There is another aspect related to the materials, and the materials are really going beyond silicon. Since morning, there has been a mention about silicon, silicon carbide, gallium nitride, and so on. In addition to these, the very large scale upcoming branch is flexible organic semiconductors, or flexible organic devices and ICs. Now these organic devices and ICs, these are primarily molecular electronic devices, and these provide flexibility to the end users, especially for the wearable and for the display technologies. These are being practiced elsewhere in the world. So maybe as a focus area of our local ecosystem here, we can also think of having this as one of the focus areas, where essentially we see that there are a lot of chemical industries around, in and around Pune. There are a lot of chemical industries. There is NCL, there is university chemistry department, and so on. So with involvement of these, if there is a very, very focused activity done on flexible organic semiconductors, and the ICs related to that, that definitely would be a very interesting outcome. Then we have the fabrication process. I think I'll not go through this. There are OSAT and ATMP facility, OSAT or ATMP facilities, where essentially the kind of skills which are required, they are different. These facilities, they require use of certain machines, and only handling those machines is the kind of skill that is required. The people who would be participating in this particular activity, they are operator level people. So they should be trained in operating those machines and getting the jobs done. Maybe there could be some people with quality inspection kind of background that also can get into this. So I think I have covered almost whatever I wanted to say. Only one point I'll make, because my previous speakers, they also mentioned something about the IT and the inclination of students towards IT. In this August gathering, there could be a question asked, why people go to IT? And the answer is very simple. Any student who is completing his 10th or 12th aspires to get IT or computer science domain. Why? One of the reasons is salaries, and the other reason is job or working conditions. Can the semiconductor ecosystem take a note of this? And can it come out with a model which will be more sustainable, more useful to their employees, because these are the employees who are going to make the roads. Thank you.
41 years of experience. In his illustrious career, he has been instrumental in bringing Rambus technology to the market, contributing to products like the Nintendo 64, Intel PCs, and Sony PlayStation 2 and 3. Mr. Patel has established himself as a thought leader and problem solver for customers, gaining deep insights into the entire product development cycle. I invite Mr. Patel.
The 12th grade passed, or they're like college grades have to learn what the world needs from them. We all need to know how to work in this world. Right? So, even before I go to the slide, I'll say one thing that maybe we are not fully aware of, and that is the world is at a crossroad as far as the semiconductors are involved. We can easily understand that we have to catch up the 40, 50 years of gap that we have right now between us and the rest of the world. But that's one part of the equation. The other part of the equation is the semiconductor industry, the way it is, it has grown till now. It's not the way it is going to grow going forward. Essentially, Moore's law, and people have talked about it, but even in the morning, some gentlemen talked about it's a volume game, right? I mean, stupid, understand it's a volume game. It is not going to be that way. The semiconductor industry, very slowly but surely moving from technology-driven volume game to application-driven variety game. So, systems point of view, I understand we should think top-down. We should also think about how we can aggregate very different designs and get the cost per die reduced even for variety of designs instead of the same memory chip or the same CPU chip. And that is happening not only here. US also has the same problem as we have. They don't have fresh graduates who are interested in this field anymore. That's an opportunity for us. Our kids can work, especially now with work from home and all that, they can work here for anybody in the world. So world is changing, we have to be aware of it, and when we can see how can we take part into this opportunity that has been actually provided. I mean, it's mind-boggling for me to learn this morning that we did not have policy in place to invest 100 million in this area, and now we are actually investing 10 billion. Can you imagine? I mean, in 20 years, how far have we come? So having said all that, we still want to draw from our past and see what we can do as we go forward. So Sankalp experience, thanks to Vivek, I got involved in Sankalp India, and without that opportunity, I won't be here today. I will be doing something else somewhere else. So selection of the trainings, like he was saying, is very important. Some of the very basic skills like problem solving, if it is not there, you want to test for it, or at least you want to inculcate it. That was done very well, not only at Sankalp, I'm sure at many other actually places. Then you want to have the trainers, at least at some stage of the training, which is actually going to make the learning count. Meaning, when you do the work for a client, or when you do the work that for a chip that is going to go, it is going to be sold, then only you learn. Otherwise, even me, going to a sort of actually premier institute, I was job ready. The heck no, I wasn't job ready even actually 40, 50 years ago. You learned a lot on the job because if you don't do the job, you lose the job. As simple as that, right? So we have to make that link between the student that we take in, some sort of sense of security that you are spending money, you are spending time, you'll get a job, but at the same time hold them accountable, कि भाई, you have to do the work, right? That was done well at Sankalp. Mindset we kind of talked about. What is needed is large numbers of engineering and actually technicians skilled in all areas. You know, because we come from that background, we talk about the design and eager to educate each other about my own problem or your own sort of problems. But Fab, OSAT, and I learned in the hallways that there are large-scale plans to train actually technicians. We have done in other areas. So I have been this time in India only for 4 days, but I already feel that, you know, in 75 years, what have we not done? That was a national challenge. So if we take this as a national challenge, even this we can do. And people are doing it. So it goes back to the awareness plan. We just need to be aware and devise the plans as holistic as actually possible, leveraging the virtual tech. I mean, now to scale is not that hard. Once you have the training, you put it online, and somebody taught me a new kind of concept, the cost of removing a doubt. I don't want to steal any more thunder, so I'll stop there. But the point is, you use the technology to somehow reach out to a large number of students. We have young population, especially when I told somebody that, you know, I have been into rural schools where even if you want to give them scholarships, they do not want to go into engineering or actually medicine. Because the parents are saying, कि भाई अभी तू 18 साल का हो गया, 20 साल का हो गया, bring in money, don't take out money. And the immediate answer I got was, हाँ वो आपके actually गुजरात में होता होगा. But I'm sure it happens everywhere. The realities of economics are true everywhere, right? So given all that, I just want to make you guys aware of one or two things that I'm involved in that is happening. I've heard about many such things that are happening, and it is good because no one is the only channel or only way to solve some of these issues. But Semix, I'll just tell a little bit about that, is an initiative by IIT Bombay. It's a center for semiconductors. And the whole idea was, how do we become more relevant in a practical sense to this issue of we have to bring up the semiconductor industry from scratch in India. Actually, there's a huge advantage. We already know what others have done. Now, we don't want to do the same thing because otherwise that will be like driving in the rear view mirror. But knowing where we need to go, we can think through and do the right things. So the first observation was that it will be an interdisciplinary exercise, at least some knowledge of what is involved in some other industries, right? So Semix is said to be a nodal point for research for translation. This is another word I've learned in the last few months, translational research, meaning do research that can bring you money right now. And more importantly, from the local needs, right? So from that point of view, what IIT Bombay is doing right now, in electronics, they're hiring new faculty only if they have industry experience, right? So small things, but that is what brings industry and academia together, right? So it's an interdisciplinary center trying to bring academia, industry, and government for actually policies all together. So you are all welcome to kind of reach out to us and see how you can be part of it as an industry affiliation, university affiliation, advisors, mentor, even as a beneficiary of some of the sort of offerings we have. For example, I don't know I have that slide or not. This is it. So let's look at this. So these are the few data points. So Semix is offering a course on packaging, on like actually power semiconductor devices. It's an online course. Anybody can sign up. If I'm actually like a middle-aged individual who has worked in any actually technology field, have done any managerial role, I can do a course like this and apply for actually becoming a manager in an OSAT factory. Why not? Because I just have to have a superficial knowledge. Otherwise, most of my other skills are actually transferable, right? So the notion that I have studied to become an electronics engineer and therefore that's what I will do for the rest of my life, it isn't true for any one of us. I mean, we have gone into management or something else. Same thing here, you can get into these fields. However, actually technology intimidating they may be, at least at some level of abstraction, these type of courses are available, which will give you enough adequate idea to be able to do your job well. And then the other example I want to give is, we talked about non-profit. The advantage of non-profit setup to cross the bridge between academia and the industry needs is very simple. It can do a sort of services type of business without giving any wrong illusion type of ideas that, you know, आज अभी सर्विस कर रहा हूँ सर, बट कल मैं अपना एक्चुअली प्रोडक्ट करूँगा सर्विस में से थोड़ा थोड़ा बचा के, और या फिर you know मैं तो उतना बड़ा हो जाऊँगा कि I can give you stocks and this and that. कुछ भी नहीं. You are training and you are giving them the first job. Then let them fly as birds wherever they want to fly. You keep on doing your job, and then maybe that is upfront. If you say it is a non-profit, it is understood that that's what their job is. University professors, we can tell them we need this, we need that, but they have their daytime job. They are willing to sort of work with you, and you can bring them in for their knowledge, but then you have to translate it from that to what is required for the job. So unless you add a value, you don't have a role to play, right? So what the sort of actually like a picture is showing is in a rural area in actually Gujarat, there is a vocational training center. It is one of the 20, 30, 50 such actually centers in that state. I'm sure other states also have it. We have actually polytechnics. Lot of work that is done even in the chip design area, for which people get paid very, very well. I would comment that that work can be done by actually technicians. We are wasting our youth by making them go through all these colleges and appearing for all these exams and then say, बस बेटा वो सब ठीक है, अब आगे इधर आके actually layout कर या फिर verification कर या वो कर और वो कर, right? And there also, so such things are actually going on, and I think as we talk to each other more, we'll find such centers, and we'll find something where we can add some actually value, right? Like I'm happy right now adding value at actually Semix. So that's all I had to say, and then we'll be happy to answer actually questions.
Thank you, sir. Our next speaker, Mr. Karthik Shankaran, CEO, Deshpande Startups, has over 30 years of engineering and leadership experience in the semiconductor and software industry. He has held various executive management roles at various industry leaders like Intel Corp USA, Synopsys Bangalore, and National Semiconductor Bangalore. Mr. Shankaran has also been associated with many colleges and universities as a member of the Board of Studies and has helped with curriculum development. Mr. Shankaran, please.
Make PDF भी है ना?
Okay. Good afternoon, everyone. So being the last speaker of a very distinguished panel, I don't think I have much new to add, but still I'll just try to wrap up my talk quickly. So I'm going to give a perspective. So if you see my experience, I've spent about 18 years at Analog Devices, where we did complete product development, right? It was not like somebody gave you a spec. So we kind of worked with the marketing and defined the products and had complete product ownership. So, and we had a complete product development team with design, test, apps, software, and product marketing. So I'm going to give a little bit of skilling required. So we also talked about today that we shouldn't be, we are today, a lot of last 20 years, 30 years, we've been working for large MNCs, large companies. But we want today's generation to work for their own, and making startups in India, or for the world. Okay, right? So if you're looking for talent, either for, let's say, startups, which are going to define cutting-edge products, right? Or looking for really high-end product development. So I had some experiences to share, okay? So going forward, so I feel that this is my observation in the past so many years working with academia and the industry. The top IITs have very good VLSI programs, okay? If you hire MTechs from them, you're all set to go, right? But then if you come down to the next Tier 2 and Tier 3 colleges, there is a gap. Yeah, the raw material is good. The BTechs are really sharp. You can work with them, but you have to do training. So this is the gap. So if you're like the software industry, like all the Infosys and TCS have a 6-month training program, right? If you're going to do that, then you're okay with going to Tier 2, Tier 3 engineering colleges. But if you are looking for people to start running from the day one, then you have to work with these colleges, okay? And I personally think a lot of interventions have failed. I'm being very blunt here. So, I don't like speaking, just for the sake of speaking, but I feel a lot of interventions, like EDA companies are given tools to a lot of these Tier 2, Tier 3 companies in the universities. They've not been used. You go there, it's all just fresh from the box, and EDA companies love them because they don't ask for any support. Only if you use, you have support. So I feel the real reason why Tier 2, Tier 3 universities have not been able to generate talent ready for industry is primarily because the faculty are not really hands-on. Okay, I'm saying this bluntly again. If you don't have hands-on faculty, there's no way you can go to teach your students to do design. Design is a very, very hands-on field. It is not something, yes, a lot of VLSI courses are there. They will teach you some theory, some simulations, but really doing the design, right? Either it's digital design or analog design, you've got to have faculty who are really hands-on, who've been through the process. And sadly, a lot of colleges are not able to, again, top IITs are different, but other colleges are not able to hire faculty with industry experience. So what is the solution here? Okay, so some of these solutions have already been attempted, and some of them have made progress, but here I'm just going to cover. So one solution, I think Naveen brought it out. I think we need, either with ISA, with government, I think with MAITI, or with IITs, to provide a curriculum with labs, right? It can be a platform, but it has to have the labs as well, and it should be open source, okay? So that the other Tier 2, Tier 3 colleges can adopt this. So it should have labs. Like I'm emphasizing labs because the theory classes are easy. You can get them. YouTube videos are available. So much material is available. It is the labs that are the problem. And can we have a platform developed and open source available to other industry? The other point is, can industry adopt some colleges and provide, I think Naveen again talked about a very good point. Marvel does this practice. I'm not sure how many other industry do that. Having faculty as interns spend a month in the industry. I have seen this concept in the US. When I was an intern at Motorola many, many years ago, I had a faculty member from one of the US universities sitting next to me. So this is a common concept in the US, but in India, I think we have not practiced it. So this is something that I think Marvel practices, and maybe, we should probably adopt it at a larger scale, and a lot of universities should be open to that, because that's how you get the faculties to get industry exposure, to understand the gaps of their students, of themselves, and address it. And the other thing is, we talked about a little bit about technology. Startups could focus on VLSI training. Yes, it is not as easy as software. You have the Messai School, for example, where they give online training, boot camps. Or you have the cost of the doubt that Samir talked about is a concept I learned from Physics Wala, where they've reduced, using technology platforms, they've reduced the cost of doubt to very insignificant number. So I feel using technology platforms, you can really scale the skilling to a next level, and we should enable some startups to really scale and teach it directly to the students. I think that's where I think the maximum impact could be there. On a different note, this is a different skilling requirement, in my opinion. This is more for OSAT, ATMP, and fabs. I think here you need a lot of training infrastructure, equipment, and so on. Again, I came across this institute. I think in the government of India has set up this Indian Institute of Skills. I think it's a fantastic development, very recent. And the Tata Trusts have partnered with the government of India. So there are 3 Indian Institute of Skills that are being launched. I think one is in IIT. I don't know, is it Patna or Kanpur? I'm getting confused. But the other 2 by Tatas, one is in Mumbai and one is in Ahmedabad. Here they're getting all the companies like Fanuc and so many other manufacturing companies to set up their equipment and have a training material as well. So if this is launched, I think Tata Electronics would also drive this. So I think this could be a very good model for training, skill development for the manufacturing, whether it's OSAT or fabs. And they also have a hub and spoke model. So you could kind of, because everybody cannot have the equipment, so maybe some of them do it in simulation. In the hub, you have the equipment. And again, you could drive this to not-for-profits as well to take it to Tier 2, Tier 3. So with that, I just want to say one last thing, is that somewhere we have to teach our students problem-solving skill at a system level so that we solve problems that we see around for India. And unless we have electronic systems, I think one of the speakers in the morning suggested that unless we build systems for our own markets, how are we going to generate markets for the chips that we make, for the chips that we test and package? So I think the decisions, I think there's a very good point made in the morning that if you are going to be doing for somebody else outside India, then the decisions are all made there, right? So if you want to sell to India, we have to start making for India. And of course, India as a start will probably move to the global place. But the starting point could be looking at, Sanjeev was talking about the morning, he was talking about identifying some big areas where, if you look at, for example, the home inverter market, the home UPS, the country has the need. India is the only country. Similarly, our energy meter is very, very specific. If you know the reason, it's because a lot of tampering techniques are used here. So it has to be really tamper-proof. So a lot of the companies, even the US companies, had to spend a lot of time in India to make sure the energy meter is tamper-proof. So these are all very, very specific India markets that we can target. So somewhere we need to inculcate this problem-solving skills at the system level. It may not be at the chip level, but unless we do that, where are we going to get the system companies from India? So with that, I conclude. Thank you. Thanks a lot.
So thanks to the panel for giving insight from multidisciplinary approach to the high-tech to the actually kind of preparing the student from the base, having faculty for internship, and having different ideas of common course which can be run with a lab running. So what I would do now is that we will have questions from the audience. We can directly ask to the panel member, or I can redirect them. Till the time if you are ready to be the questions, I have one question I want to have for 2 different people is, we have heard many things now. And if you want to, listening to others, one thing that we want to take away from here and do something differently as a organization body, as a panel, what would you, each one of you will propose one thing that needs to be done that we should ideate, and that should actually be kind of be thought through with the association, so that it becomes kind of, out of that we can have one or two ideas. So I would give chance to each one of you from here, and then by the time, if anybody is ready with the question, raise the hand, mic will come there. So we have, mic can go there.
I think one of the common theme that we are all seeing is about the, part of the skilling is the whole tools, infrastructure, and all of that, right? There are too many bodies, too many players playing it. If we can centralize it to be a central place, whether it's ISA does it or METI or AICT does it, and then we have one side what we call as beneficiaries, which is all universities, college students, and on the other sides, all the people who want to give, right, from the industry and others. And then this central body can drive that open source labs, curriculum, and the skilling by scaling it from the contribution from all the participating companies. That could be a good start from here.
Infrastructure from association is great. We have a lot of people who want to have that. If we can actually do kind of a merit-based, performance-based kind of giving the infrastructure, then infrastructure would be actually useful, used, and not just kind of bought by the college and not used at all. So I think that we'll think that's one idea.
One of the things that I'll like to add is basically major problem the country is facing at present is the GER, gross enrollment ratio. Our country has so big a population, and out of them, out of the eligible youngsters, the ones who get into the educational system is a very small fraction. Presently, the gross enrollment ratio is about 27%. There are attempts being made to raise it to 50%. That means that out of the total number of youngsters who are probably the, so to say, future young human resource, really more than 70% are out of the educational system. So we need to really target something for those ones who are out of the education system also.
Thank you, sir.
Yeah, so I'll just kind of repeat what I'd said in slightly different words. Live in the present and in the future, don't live in the past. Instead of saying, you know, VLSI design or semiconductor is very hard and we'll train them over long sort of periods of time, make it easier. Why can't a physics major, why can't a chemistry major, why can't a software guy do also chip design? And the US is actually thinking that way. You know, you start the design from Python and a lot of stuff, why do I need to learn 5 different languages to go from spec to GDS2? Why can't I use the same language?
Yeah, I would concur with Naveen on that platform. So I think it is high time that we develop some educational infrastructure in this country. So I would vote for that.
So good evening. Before my question, we all are convinced that someone from the training background itself with a good hands-on will be able to train students in a better manner. So one thought that came up through this discussion was having faculties from industry background, industry experience. That's one. But my question will be like, let's say for now, since we have faculties who are not hands-on or not all of them are from industry background, what are the ways we can encourage, motivate them to have a hands-on so that they are able to propagate the skills in the right manner across to their students? That's one. Just in accordance with this question, another question will be like, what can be, and anyone or even all of the panel can answer this. In that case, what can be really kind of incentives for those two or the years for not going through or even being not open for getting themselves hands-on. So any penalties to that? What kind of what can we propose here in this today's program? Right?
Maybe I'll direct this question to both Naveen as well as maybe Sharik, I'm sorry.
I think
Naveen.
he's a part of it.
Basically, say this year we have rolled out all over the country the national education policy. And as a part of NEP curriculum, the internships are compulsory. It is not, optional. Anybody cannot deny that. The penalty is already there.
My question is for faculty. Faculty
I think what the
not
question, let me repeat the question, sir. Question is, faculties, when they are hands-on, they'll be able to do a better kind of skilling for the students. So how do you enhance, encourage faculties to be hands-on? And when they get a hands-on, when they go off from it, what should be the penalties? What his question is? If you can answer these two questions, that will be great.
Yeah. Basically, if we just look at, if we try to implement anything, any educational experiment, we have the faculty as the target. But actually, in the morning, since morning, there has been mentioned that there should be academia-industry partnership. Now, if at all industry is expecting certain skills, they can come forward and elaborate on what skills they want. Because if they just simply say that we want these skills, and the faculty take it by verbatim, they probably will only implement the way they understand. They have to get the nitty-gritties of it, and that nitty-gritty can be only available, as you rightly said, that if the faculty is exposed to the practical situation. At the same time, the industry also should come forward and elaborate on like what are the skills or what are the things which are required. So if we have a program like this, without spending much time from the industry as well as academia, if there is a definition created and that definition is handed over to the faculty definitely would take.
So in that case, what can be the incentives for faculties to undergo such training?
No necessity of incentives, because that is
Then
their
there has to
job.
be some penalty as a motivation.
No. That's a primary job. Say people have to educate. The faculty members have their
In our curriculum, but I don't know how far low power design techniques have moved. And I want to know those advanced techniques. So for 4 weeks, if I am there in your office, how can I learn on those techniques, right? The new techniques that have come up. And the other pair of two faculties says, we have been teaching about VLSI testability, VLSI design for test and testability. But again, as we go into 5 nanometer, 3 nanometer, there are advanced test models and test techniques that have come in, and I want to learn about that. So that way it was driven about in a day, then we'll enable for some of your hands-on practice. You will curate some of these things, and after 4 weeks, they had 3 deliverables that they took back to their college. One was a learning what they had. Second, they created a set of slides which they can use to go and teach in the next semester. And third, they modified their lab to actually introduce those advanced low power or design for test techniques in that, and then took it back there, right? Now the incentives for them, penalty for them was that they left 4 weeks of their holidays or vacation during the semester break to be at my office rather than with their family. But the incentive is that now I know they have done advanced one. I'm actually thinking of moving up to do a research project with them where I can give funds to sponsor a PhD student, to do a research project, and then get something meaningful out for me and them. So that's one model I'm implementing, and it has both incentives as well as some penalties.
Well, that's significant.
Thank you.
Any other panel?
So what I'll do is now, I think the time is, I have got continuous indications from the organizers.
No,
the
but
time is over.
I'll just add
And
to
others
this.
are waiting, so we'll...
Not a question. It is just for addition from my side. My target was also faculty, but from the angle that I would be open to give them any internship opportunity.
Thank you. So, last one now.
Hello, this is R.S. Gupta. So actually my question is, when we are talking about academia and industry, we are talking about faculty. And as Naveen-san says, these faculties reach out to him, they did not spend their time with the family and other things. Why this initiative is taken by faculty alone? Why not the institute decide? Why not the institute say that, oh yes, you are going for a advanced training for 4 weeks, for 10 weeks, whatever is required to achieve that target? What is the I mean, why it is stopping academics, colleges to take this kind of decision?
Can you repeat the question?
See, my point is that when we are talking about industries and academics association, and we are saying, okay, industry to reach out to college, and professors or the lecturers to reach out to the industry, so why not institute decide? Why professor has to suffer in that case? They reach out and they say, okay, this is advanced course, you go and do something and then teach the student. I mean,
Sure. So the point is valid. I think it is not only colleges reaching out to the industry, not only industry reaching out to college, professor reaching, everybody has to play the role. So I'll just summarize this and close the discussion now. But I also want to share my learning because there's a faculty members here, industry members there. And I was in Texas Instrument for 15 plus years and we did reach out to IIT Kharagpur, Malma Matter, then we reached out to College of Engineering Pune, reached out to RSC Trichy, RB College Engineering, spent millions of dollars over 10 to 15 years. But nothing sustainable happened. So when I went to college campus in BEB College, Hubli, Sankalp started in college campus in Hubli, I realized that when I was dealing from a corporate, I had a chip on the shoulder. Why don't they understand? Why don't industry, academia don't understand? They are not interested. They are not driving it. I think that chip on the shoulder was what actually stops us from working from academia. So when I went into college, I understood that academia runs with the speed of students' enrollment to students' exam to student pass out. And their cycle goes by that. Industries, if I say something tomorrow, it has to happen tomorrow. And if it doesn't happen, industry loses the patience. And we expect them to do independent of students' life cycle. I think that's what I was doing. When I went to Hubli, we learned it. The chips of the shoulder went down. I think I had to be humble to understand that they have their value, I have my value, and how can we work together? And why I'm saying this because despite having no money in Sankalp to work with faculty, compared to TI, we had multiple millions of dollars, right, over years. We could actually get one PhD on doing analog A to D converter, 21-bit design. Completely designed, simulated, and done, right? That PhD happened and PhD happened, right? On a chip design. We got 3 chips coming from BB College for 3 years. After the 25 students joined as a AC course, and then somebody from Anand Baria, who is currently the Deshpande CEO, used to come and teach the course over weekends. And they used to take out the chip using Euro practice, and the chip was tested with no money there. So what is required is basically industry, academia to work together as partner, equal partners, understand the life cycle of the students and faculty's limitations, and don't try to boil the ocean. Don't try to change every faculty. There are faculty enthusiastic who have time and who are able to spend that time. Take them out, help them to kind of take some courses, get them internship as Marvel is doing, and guide them, support them. And I think we are doing that in Anandra Power College and also MMCA here. 2 faculties are given 100% to Vidyalip. They don't do anything other than Vidyalip program, internship, plus 2 subjects they will take which are required for embedded. And those 2 subjects will be driven by Vidyalip's curriculum, flipped classroom model, and under that model. I think that is we are trying, and I'm sure we can learn from that and we can share and implement. So 2 things will implement: infrastructure common. How do you do the infrastructure common? And make sure that we actually kind of give it to the right people and it gets utilized and then its skilling happens. And second is how do you take the faculty internship, make it kind of slightly more structured and make it workable. So thank you for the panel and thank you for all of you for being patient and being there.
A very big round of applause. Getting these 5 great people, okay, under one roof, okay, it's really heads off. I know Vivek for so many years. He's a classic example of living multinational and creating an Indian company from place like Hubli, okay, and Karthik came all the way from Hubli, Naveen came from Bangalore, Samir came from Mumbai, and Dr. Shaligram. Wonderful session. Thank you very much. So, ladies and gentlemen, now, okay, one photo. So, ladies and gentlemen, before we move to last session, we have a very interesting person with us, Dr. Virappan. Dr. Virappan is chairman of IESA and he is founder of TISOL. TISOL is also working into semiconductors, and this year TISOL has crossed 1,000 crore of revenue. So it is one of the great semiconductor emerging company from India. He has earlier worked in Motorola, Wipro, and it is nice to have Mr. Virappan to share his thoughts about semiconductor industry. Mr. Virappan, please.
Good evening. Okay, I'm supposed to come in the morning inaugural session. Sanjeev called me and Ashok, I said I'll come. But yesterday I was in Coimbatore for a very important event. Then I booked a flight in the morning at 6:20 today morning, which is supposed to fly via Mumbai, then to Pune. That flight got cancelled at 6:20. Then 7:30, there is a flight which has to come via Bangalore. Bangalore to Pune flight got delayed. Then I thought, okay, let me take a flight. So I took a flight at 9:30, which goes to Hyderabad, Hyderabad to Pune. So all the three seats, the ticket was getting changed, and finally 9:30, it landed at 11 something in Hyderabad. The Hyderabad to Pune flight got delayed further. So finally I reached the airport at 2:20, thanks to Indigo. I think my apologies for not being Sanjeev and the MCCA. My apologies for not being in the morning. I think first time I'm seeing a Chamber of Commerce conducting a semiconductor ecosystem event. I have seen other, Semicon Association or ISM, the governments have done. But first time I'm seeing a Chamber of Commerce. I have done Bangalore Chamber of Commerce or the Tamil Nadu Chamber of Commerce. I have never seen a Chamber of Commerce, conducting an event towards semiconductor ecosystem. I think kudos to MCCA and Sanjeev for this. That's one. Second is, I have gone through the speakers. You see here, right? I can see Karthik, Samir, Naveen, Vivek Pawar. I can name it. Whoever from the morning, you can never see. These guys are all like 2 decades in India. All of them have worked in this field for the last 24 years. We know, right? Here the system started. We can say about from 2000. Earlier, TA came to India in 1985, 15 years, but none of the much companies came during that period. All these started in the end of 90s and then beginning of 2001. Samir, you will never get, I think Sanjeev and the MCCA, getting these people to a place like Pune is wonderful, good effort. I think it's a very, very, useful thing for all of us. That is number 2. Number 3 is the timing. I think there's no better timing for an ecosystem conference than today, because we have been talking about so much of the, Ashok always says, we're going to have 100 billion by 2030, we're going to consume electronics in the country and so on. Till, as of today, we don't make a single chip, means wafer out of India, means commercial wafer. We do some non-commercial wafer, but commercial wafer, as a country like this, we have so many billion people, and we have so many wonderful heads here, we don't make a single chip out of the country. So we used to think it is a shame on us, right? Which we are talking, I think, Karthik, all of us have been talking for the last 20 years about the same thing. We have to get a fab. We have to get the OSAT and so on. I think now looks like the dream is coming true. Looks like. Hopefully, if Tata goes in Dhalera, Gujarat, the first wafer will come out as per them somewhere in 2026, 27 is what they're telling. The first wafer out of India will come out. So that's a good news for all of us Indians. Then second is the OSAT. As of now, we have 1, 2, 3 announcements of OSATs. OSATs are coming. Another 5 or 6 are in pipeline. So it is about 10 or 12 OSATs are going to come. And another 2 fabs are going to come. This is all in pipeline. So there is no better time for the country. Now what happened, we have all this. We have talked about, all of them talked about the skilling. Design, we have about 30% of the world design skills in India. We do. About 30% of the worldwide high-end VLSI designs are being done out of India, and we have really done well. Most of the complicated SOCs are all done out of the country. We have wonderful power, we have a wonderful ecosystem. Colleges have developed, all this is available in the country. Now coming to OSAT, the post-wafer side, right? Wafer also I think fab. Then OSAT, the skill sets, right? When TESOL started in 2004, about the country had 40 test engineers. I'm talking about the physical test, not the software test engineer. Physical chip engineer, only 40 in 2004 when TESOL started. Now we can proudly say we have more than 6,000 test engineers in the country. Now, thanks to, we developed at least 3,000 to 4,000. So how Samir did in Sankalp for VLSI, I think TESOL did for test engineering. So we have created that type of skills in test side. But the next is assembly, packaging. All these skills are all, till now we have to import. It means Indians are all there, but we don't have here. They have to come back. They have to come back. So we have actually bought a lot of people from the US to do this WOSAT thing. But the problem is now more and more are WOSATs coming. We need the skill sets to be done here. I think this conference is very, very clearly skilling. One is the design. The second is the fab, the WOSAT. These are all, we need to have the skills because when we have all this, we are talking about this, we have to develop these skills. I think the Institute, IESA, MCC, all of us together can work. How do we bring up this skilling? That is one side. The other is, all this need power, water, I can name gas, chemicals. I think so many other things. That supply chain and logistics. See, the chips have to come out and go at no time. Whether it is possible as of today, we have been working with the government. IESA also is putting a lot of, we have done a supply chain report. So I think Sanjeev has worked in companies like Arrow and all, how distribution can, because this all needs, it is not just like that, it can't happen. So we need a right distribution, means supply chain, we need a good logistics, customs, support, all those things are needed. I think we all have to work with the government to make sure that this ecosystem, chemical, see, gas, we didn't know. IESA met somebody from the chemical side, chemical side. We don't have, that cannot come through seaport to India. It cannot come by air. So in what, it has to come to India, how? Because a lot of regulations. So I think we have to gear up. I think that's why this conference is the right time. We have to make sure that before all this comes in the next 1 or 2 years, as a country, we need to gear up with all these systems. That's why I said it's timely. So kudos to Sanjeev and MCCA for doing this. My apologies for coming it late. Thanks to them for giving an opportunity to speak. I want to spend more time. For want of time, I think I wish MCCA all the very best. I'm also looking at some more announcements which has come to Maharashtra on semiconductor side. Please make sure that, because it has to come across. Now we are seeing a lot of announcement across. I have not seen an announcement in Maharashtra coming. Let's all hope something will come into, because Ashok Chandak, the ISA president, is from this state. Sanjeev is from this state. We have so many people from this state. Make sure that we also, this state also gets some semiconductor companies. Thank you very much and good evening.
Thank you. In 5 minutes, you will be here. Hello. Good afternoon again. Before we get into a little bit of a detailed session of our SCDG team, I would request Mr. Rajendra Chodankar from RRP Electronics to share few of his insights about his own industry and about semiconductor as a whole. Mr. Rajendra Chodankar, please.
Good evening, everyone. Good evening, MCCI, Mahata Chamber of Commerce, for inviting us for this wonderful occasion on semiconductors. It was a very interesting session. I had come since morning, and I was listening to every part of it because it's been a long time that we have been talking to the Maharashtra government, and we have been probably which is probably coming official, that we are the first company in Maharashtra to have been offered an in-principle approval for a subsidy for setting up a complete semiconductor plant from end-to-end solution. We've already got an in-principle approval for an OSAT facility, and work has also commenced in full swing. We have started investing a lot of our personal contributions to this OSAT, and we should have a OSAT functional on the September 16th. This is possible mainly because the in-principle approval has come in from the government. We should be having a good amount of subsidy, very attractive subsidies. We are also working very closely with the government to offer us a subsidy for the fab. The government has already allocated us 20 acres of land at Taloja, where we are going to set up a better, bigger facility for OSAT and fab. HMT Microelectronics have been closely working with us to offer us this buyback of their wafers being processed into chips. And we're also talking to two big giants, and hopefully we should be coming up with some very good announcements in the magnetic Maharashtra. But yes, and every time in this discussion, I was just trying to understand, yes, we're talking about, and I really agree to the panelists who are speaking there, that, we have to, we have the, probably the technology from the technology provider, we have the subsidy, we have our own contributions, we've already invested a few hundred of crores to set up this OSAT, and then we are thinking of how do we get this manpower. So that was one of the biggest challenge, which I think the panels have addressed, and we are trying to work very hard right now, depending upon the technology provider. My managing director, Prashant Deshmukh, my CTO, Apurva Raut, they are working very hard to get the right people. And we hope to do something good in Maharashtra. Obviously, there's a lot of things being spoken in Gujarat, and actively government is really working hard to make this happen. Maharashtra wants a good facility. We come from a background where we have been blessed by Dr. Anil Kakodkar, who has been actively working with us at this age. He puts us to shame sometimes. And that's why we feel that we should be in a position to launch our OSAT on the 16th of September. We started this actively on 23rd March when Dr. Kakodkar and Sachin Tendulkar graced this occasion. And good part about this is that Sachin Tendulkar also has invested a good amount of money as an investor. The cosmic energy, the universe is trying to do something good for us. We come from a very different background. We are a very strong company working for the Indian Army. We do a lot of border protection surveillance systems, hard kill anti-drone systems. We've been doing this for quite some time, and this opportunity came up through the blessings of Dr. Kakodkar sir. Good people are joining. We have some couple of investors who are here sitting who have got the capacity to infuse in a few hundred crores in this facility, and they're doing that because otherwise, you don't have this OSAT successfully commissioned by the 16th of September. But thank you very much for everyone. Thank you, the audience, for listening to this, and let's hope that on September 16th, we should come up with an OSAT fully functional in the government, in Maharashtra, in Mumbai, in Navi Mumbai, Mahape. Thank you very much.
Thank you, sir. We are at the end of a very fulfilling day. The last session for today is a session by SEDG team. May I invite Mr. Chikteri on the stage, please.
Thank you, Anaga. I would like to call our SEDG team over in the stage. The plan is all of us. So the plan is all of us who have started this SEDG under the Electronics Committee of MCCI would share our last 1 year's experience, what are our takeaways and what are our way forward. So I would like to call all the SEDG team members Abhay, Bhairav, Rutvij, Amol, Sanjeev Keskar, of course, he is now part of SEDG. Milind Jape, Vinay, Milind Jape कुठे ओके मनोज सोमनजी तुम्ही बसा सर 2 मिनिटं and anyone else from SCDG huh madam Gunjusha so before before our team shares their thoughts and this thing, I would just quickly talk about 2 to 3 minutes, and all of us would probably restrict that time because it's Monday and it's evening is coming close. So just to tell briefly about SCDG, somewhere around the same time last year, 2023, there were some messages exchanges happening on MECF and MCCI WhatsApp group. And then best week, some of us like myself, Abhay, Bhairav, we took capture of some of these messages and thought that why don't we start something very constructive and qualitative about semiconductor, because at the end of the day, WhatsApp cannot be a business domain. So we decided, we spoke to Mr. Prashant Jogrekar, Mr. Prashant Girbane, and said to them that let us create a working group reasonably dedicated to semiconductor ecosystem development group, which would facilitate some ecosystem developments which comes to Pune and Maharashtra, and of course the other part of the countries as well. So that's the brief formation. We started WhatsApp group, then we started, then what we did was we conducted about 8 to 10 lectures of a lot of eminent personalities in semiconductor field. Dr. Sharigram was one of the this thing, then Dr. H.S. Jatana, multiple people we visited Semix from IIT Mumbai, got into some synergies with them, and then we were having a dream to have this kind of a conference wherein we would try to collect lot many stalwarts, lot many attendees who are interested to and keen to do something about semiconductor as an initiative, as for part of electronics developments in India, and that's what our way forward. So this session or this conference is just an instance, and we would be taking this ahead with so many action plans and all those things, and we would come up with some short-term planning and long-term planning with this entire group, and we would like many participations, active participations from all of you, but not to that, but at least some of you. So let Abhay, you would like to speak now?
Yeah, first of all, thank you MCCI for letting us form the Semiconductor Ecosystem Development Group to begin with. In maybe I think August 2023 we started with that, and looking forward we spoke to a lot of people and then came up with some some plan, some outline, and then started working on it, and now here we are conducting the Semiconductor Ecosystem Conference with MCCI and other STPI and ISA. So just to, so what we have planned is that we would just give you a few points, 2 to 3 points that we think that are kind of takeaway, and those things that are important coming from industry perspective as well as academic perspective. So I have just written down few things that I think, what we realize is that one important thing from manufacturing point of view is that we need fabrication equipment if they are indigenous, because the manufacturing cost is very high. So reducing those costs by having indigenous equipments would be a very great thing. Second thing is that I come from RF background, so I have personally observed that speaking to different academic institutes, that we see that, when it comes to equations and all that, students turn around and, start walking out. So there we have to generate that interest that somewhere lacks. So we need to do that so that students start to take actual interest in it. That is there. And of course, the discussions that we have, they focused on MSME, giving opportunities to different MSMEs. So doing all those can be few points that I take away from today. So I'll ask others one by one to, Bhairav, please.
Good evening, everybody. First of all, I would like to thank everyone for being part of this event. Myself, Bhairav Shah. I'm a microelectronics graduate and currently a practicing machine tool guy. So as a hardcore machine designer, I have constantly felt the need that Pune, being blessed with the legacy of automobile industry, already has an ecosystem of building special purpose machines. And this ecosystem of building special purpose machines has people who have experience in meteorology, have experience in material science, have experience in precision machining. All these skill sets were the same skill sets with which Taiwan started. I'm talking about an era before TSMC. Same were the skill sets with which China started. And I believe that this has to be the stepping stone. Mostly people think that semiconductor is something, semiconductor industry is something that is only a ball game of big players, but it is not like that. Each and everyone in the ecosystem will have to contribute in this particular field where their expertise in manufacturing will play a key role. And that is what we are trying to do here as SCDG, where we are trying to bring together engineering experts from various areas and how their skills can be repurposed to make the dream of India becoming the hub of semiconductors come true. So that's all from my side. Jai Hind.
Namaskar. I think we spoke during the fabulous panel discussion. Couple of points I just want to make. We have been struggling with the semiconductor ecosystem for almost more than 2 decades. But there is a great window of opportunity that has opened up because of various reasons like geopolitical thing, government initiative and all those things. So we should make full use of that to the last drop, And we have to all work together for semiconductor ecosystem stuff. Another very important point, very relevant to MCCI and the overall thing is training the trainers in semiconductor. That is, I think it comes out in multiple ways. You have all the cadence synopsis tools in the colleges, but faculties themselves do not know how to run them well. Therefore, students suffer. So there is some quick intervention that we have to think about in that space. And last point, which somehow did not come in our discussions for whatever reason, is that if you want Indian semiconductor company doing things for India, we also need India-based VC funding capability specifically targeting towards semiconductor, which is currently missing. So that is also one of the points we have to explore the possibility of it. Okay, thanks a lot.
Milind Jape, please.
Thank you, Ajit sir. It's Milind Jape. Spent almost 20 years in semiconductors, right from some part of design to fabrication to assembly test and the final distribution. So a lot of things were discussed today, many dots to be connected, converted to action items, what can be done. So I'll just mention few points I feel is important as a conclusion, along with other people. First of all, we heard about fabless ecosystem, right? Many people think fabless means just design. But it is not just design, it is design and bring up of that chip is a responsibility of that company. So they need to also have designers as well as who can bring up. That means test, develop, bring up, right? So can ecosystem of fabless sustain without fabrication plant? Yes, it can. It has been happening all the while, right? Because it's a global world. What happens if there's a fabrication facility in India? Yeah, because then we can reduce the cost. The local import duties will be reduced. More OSATs and ATMPs can come, right? Because they are currently more Thailand, Philippines, other places, right? Like RRP is coming here, which is a great news for all of us. The last portion we heard was skilling and scaling. And I personally feel, not because I'm running a training company, but because that has to be local. A technician cannot migrate from one state to another state just because of job. He or she has to live around the company, at least in a nearby distance, right? Because he cannot afford to go around. Maybe a very senior engineer can go far. A Bangalore person can come to Pune. So I personally feel that though all the three are equally important, skilling is important because without people, the machines can't do much. And I got 3 points which I gave it earlier to Ajit sir for me to mention here. One is that, as a lot of panelists said, that we have to develop interest among students, as the trend is to go into IT. After engineering graduation, electronics, they go to IT. So how can we develop interest in semiconductor? This is number one part. Secondly, how can we make training available for them at a lower cost? Just clear the concept. Third, how can we tell them that semiconductor is a software parallel? And there is a career, and there's also a closer package available so that people can generate interest. So I think it's a multi-stage skilling staircase we need to climb, and I believe with all of us working together, it is possible to do that. Thank you very much. Jai Hind.
Amol Vedak, please.
Thank you all for coming here, and thank you MCCI for inviting us. I'm Amol Vedak and I run a company called Easy Reach. In this group, I represent MSME. Now, if you see, right, really, this is actually for us. Okay, we are the sufferers and we are the beneficiaries of this semiconductor stuff that is happening. We are the people who suffered during COVID days when nothing was coming from China and we were not able to deliver. This is a chance for us to actually overcome that. This is a chance where, some of the panelists, I remember, they were talking about, you need a scale or you need a lot of money. Well, you know what? Together, we can come together, we can pool in the money, we can pool in the expertise, we can pool in the skill sets, and we can make it happen. Okay, as far as consumption is also concerned, we ourselves are the consumer of these semiconductors. So for us, we don't really have to go to a lot of large companies, we just have to come together, that's it. And being here, I'm taking this opportunity to overcome this challenge. My appeal to you all, especially the MSMEs in the listeners, please come over, please meet us, please register with SCDG. We are actually taking these companies to the national level as well. So please come over. Thank you.
Gunjusha, please.
Thank you, sir. Hello, everyone. I'm Gunjusha, co-founder of Ignity InTV. I have joined this SCDG group in September 23. And we were trying to figure out a way forward Maharashtra-centric semiconductor journey. And within 8 months, that is today, we have a first of kind semiconductor conference in Pune. And all SCDG group members were trying to explore best possible connects in semiconductor domain. In that, we get all knowledge of fabless ecosystem, semiconductor manufacturing processes, and semiconductor ecosystem. Along with that, we got to work with Industry Academia Connect and resource management in the readiness in the future. In automobile industry, as per in my domain, there are a lot of requirement in electronic stuff to make ADAS technology. So for that, multiple sensors, high-speed processors, and chips are in huge demand. Apart from that, BMS also required semiconductors. So as a part of SCDG, I feel confident that many of us would float a startup in semiconductor in future and will contribute in Maharashtra's or India's Make in India mission. Thank you, Jai Hind.
Now request Dr. Vinay to speak few words.
Good evening. My name is Vinay Kulkarni. I have a lot of semiconductor industry experience, but outside India. I always wish that I bring my expertise to India and help India grow in the ecosystem of microelectronics. And I think this is a good start. What I'm seeing, what we are seeing here today, we've witnessed a lot of talks on the semiconductor ecosystem. And in India, I think anything to begin, we need some kind of a movement or a revolution. And I can say that this is like a historic day today, and the revolution has begun. And we'll see that the momentum only grows ahead. Jai Hind, Jai Maharashtra, Jai Bharat.
Just two more things. I would now request Mr. Sanjeev Keskar to speak few words, after which my colleague Rutvij would speak about few minutes on the e-fabulous stuff which he has studied and have been doing something. And then we would close. If anyone is interested to ask us any questions, he or she is welcome to do that. So Sanjeev ji, please.
Thank you, Ajit ji. Yeah, I'm Sanjeev Keskar. I'm based at Bangalore for last 28 years, but native of Pune. And I was looking for opportunity to do something for Maharashtra or something for Pune. And when I got a first opportunity to meet this group, ACDG group, I was so impressed with the passion and selfless interest to really do something different for semiconductor ecosystem in India, and decided to really work with them and engage with them to see what all can be done. So very happy with the today's conference, but this should not be the only, what I will say, a one-way communication. This is just a start. As Virappan mentioned, electronics and semiconductor is a huge opportunity today for all of us. And moving forward, what all we can do, this group will definitely try to sort of conduct such workshops or such conferences moving forward. But apart from that, we really want to do sort of a collaboration or joint ventures or technology partnership. That's what we are looking at. Means you come up with your problem statement that, okay, I'm interested, I'm into chemical, and now how I can support these wafer fabs which are coming in. Or you come to us, okay, I'm manufacturing connectors or some cables, okay, and how I can take advantage of electronics growth. Or some even basic raw material like copper clad or something like that. Okay, so we want to create a sort of a knowledge bank here where we know what the end customers are looking at, we know who are the best technology partners in the world, and we want to facilitate a collaboration between you and end customer. Or if you have a product and you are looking for a customer, we will figure out how we can help you to reach out to the market. So this is not going to be just such one-day workshop. It is going to be a long-term plan to build Maharashtra ecosystem for semiconductor. And we look forward to active participation from all of you. Thank you very much. And Ajit, thank you for giving me the opportunity.
Yeah. Just before Rutvij start, I think Rutvij wants to show some presentation. So I think we will have to get down to ours, please. Yeah, one group photo we can take, yeah. Thank you. Yeah, so before Rutvij starts, I just want to make everybody's attention in your conference kit. We had put one very simple single-page flyer wherein you would know what we have spoken, and at the end there are contact details, so feel free to get in touch with any one of us, and we would be more than happy to work with you. Thank you. Over to Rutvij now.
Thank you so much. I'm just taking a sec to load up the presentation.
Apologies, I just wanted to mention that we also have Mr. Apurva Kapseji, who has been here from Marvel, but he has been associated with us who was also there for one of our lecture series, and he has been working on something for fabless ecosystem. There's something called Semiconductor Association Pune, and we have been involved with him also working on that as well. So I just wanted to mention, and thanks Apurva Kapse sir for attending today. Thank you.
Okay. Hi, my name is Rutvish Pathak. My experience is in product design and engineer, like IoT. I joined like SEDG a year back because I was just interested in understanding this ecosystem, and I was quite excited to contribute. So we started conversations on what sort of, as a new group, it's difficult for us to establish a certain sense of credibility, both in terms of academics as well as industry. So what we decided, or what we came upon, was having short, small prototypes which will help us establish ourselves as serious players who have access to IP, as well as engineers. It will be important for both MSMEs to have some IPs that they've taped out, developed, as well as engineers who've done some simple projects and who've basically contributed to the entire, like from going from, let's say, point A to B, like from designing to the final tape out. I think it's very important to like close the loop on various things. So in this research, we came across a platform called eFabless. So eFabless is a platform which is, I think it's a consortium of many industry players, but the most important thing that we need to understand is they're working with global foundries on their 130 nanometer process node. It's completely open source. I think Mr. Bisnoy was talking about the importance of open source for proliferation of various semiconductor technologies. So, in short, this is a proposal about making your own chip. The cost, it's fairly commoditized by eFabless. We've been in touch, and with eFabless, we've had some calls, as well as we've privileged enough for, like, this is an eFabless presentation that I'm showing you. Okay, let's begin. So basically, eFabless has a program called ChipIgnite. It comes for $9,750, which comes to around 8 lakh INR. They give you access to a small 10 square meter area in which you can put your own logic and test. Essentially, and I think one of the most important and biggest things is they have the entire RTL to GDS2 pipeline open source. I mean, it's not the best tools. I mean, I've looked at some of the tools. They're not industry, I mean, they are industry standard, but they're outside the UI, UX, or those things that are not up to spec, but it's okay, it's open source, and that's the most important thing. That allows us, our engineers to, let's say, create and fork our own softwares, as to say, and create the entire stack from us. So the important projects are like OpenLane, which is, let's say, the superset of these sets of tools. So eFabless has also been kind enough. They've told us that once we get into the shuttle, essentially they'll be offering updated support for anyone who's interested in designing, essentially. From the initial design submission to the final tape out, they're offering in 5 months and 100 pieces, which is fascinating. And I think as a prototype stage, I think it's super attractive for MSMEs to, and it doesn't take that big dent in their R&D budget, I hope. So basically, how do they do it? This is essentially the pipeline in which they play. You don't have to do the entire thing from ground up. The most important thing is there's a platform called Caravelle. So essentially what you're seeing, the green stuff there, it's a RISC-V processor that they've given. I'll show this in the next slide. So basically it's a processor with pre-built IOs and communication buses that take care of the entire, let's say, the housekeeping stuff that you need to write the actual code. So basically, then you put your own logic into the container if you're using the software terminology, and that gets plugged into the entire chip. So essentially, this is what they offer, like the design and Caravelle picture you see, that's the IP that you get, right? And for a, I think, additional amount of money, they provide you with a dev board as well. So it's a very exciting proposal in terms of an SEDG collaboration. So this is just some basic overview of the SoC platform. So as you can see, it's, I think, in my opinion, in my limited opinion, I think it's fairly powerful. They haven't mentioned it, but let's say the frequency of this is 33 megahertz, which is a bit low, but it's okay to do some basic stuff. In their proposal as well, they've offered some 3 different types of template chips. As you've seen, Caravelle, Caravan, and OpenFrame. So basically, the TLDR is they offer 38 IOs. It can be, if you want high-speed IOs, then it's a Caravan, the platform that needs to be used, as well as the analog stuff. OpenFrame is, if you want to do every single thing from the ground up, you would use OpenFrame in some way. So I think the one more thing I would like to add is eFabless, which basically they're trying to build, so it's a fairly new company. It's been 8 years. But what they've done is they've established themselves as a platform. So basically what that means is they have chip design vendors as well, who have IPs on the platform that can be purchased. So this is the list of IPs. Some of them might be open source. Some of them are paid, essentially. But I think for SCDG and for as a beginning or the next step is for us as a team would be to take this proposal fairly seriously in terms of building our own capabilities as well as testing out and maxing out what needs to be done in terms of taping out a chip. So essentially, what I wanted to put across to you guys would be, we're looking for stakeholders in multiple different domains. The first domain is basically MSMEs who have requirements, essentially that want specific chips, that sort of a thing. Second is, I would say, mentor pool or someone from the industry who understands and can, let's say, push this project across. And the third would be the academic institutions that are more than happy and willing to contribute both, let's say, their time as well as manpower, essentially the people who might be required. And if this is something you find interesting, please feel free to find me after this particular program, and I think we can start taking down some names and we'll notify you about the next steps. Yeah. Now that I've said, I'll hand it over to Mr. Ajit, who'll take it from further. Thank you. Thank you so much.
Yeah, thanks a lot, Rutvij, for such a useful stuff. I would now request Mr. Samir Patel, who is actually an advisor to eFabless Systems. Samirji, please. Thank you.
Yeah, so this is such a happy, actually, coincidence. I like the eFabless offering of actually prototypes for $10,000. Because people have talked in other forum, the high NRE barrier to actually making chips. And in the old days, we used to do the designs where we have the prototypes of the system. Then we go to the business guys or even our own actually company managers and say, sir, we can build it. And then they approve the budget and then we do the final chip. Now, obviously, the large semiconductor companies already know, they already sell actually parts. But if we want to get in, and especially small glue chips, and a lot of things are happening. For example, for energy meters that I think Karthik or somebody talked, a chip from Renesas and a chip from actually TI as the main chip are already approved. So for the remaining of the chips or the glue logic, if you can put it together, your own logic, and actually try it out with some such platform, then it could be your own actually confidence building that yes, we know we can build the full actually system, as well as at the same time you can give something to your potential customers for them to make sure that, yeah, this is real, this is not just some talk, right? So it was just, we had not planned or anything, so we can talk offline more. But some of the things that you were not sure of, I can even answer. So even the IPs that are actually proprietary, they have flipped the IP model. So what you pay, at least as an experimental thing, will be very nominal. Because the idea is that, let's say, suppose if 10 guys try out some chip and one guy is actually successful, he will pay for it. And there is no concept of stealing or anything because they already have it's actually Skywater Fab right now, not GF, but they are actually working with GF, and GF and Synopsys are actually investors in eFabless. Google also has been helping them a lot. So it is all one specific instance of the open hardware initiative that is overall going on. And that's what I meant, like, you know, it's very important for the established industry to say, hey, we don't have the skilled engineers and how come we have to pay them, fresh engineers, actually 20 lakh rupees. That is actually the problem to be solved. But the bigger opportunity is to make your chips for your applications, for your markets, and there the competition may be China. We are not even worrying about marvels of the world, right? So it's just very happy. I mean, you didn't, I might steal these slides from you and talk about in some other venues. So if you have any questions, I can answer, otherwise we can talk offline. And a lot of such things are actually happening. If you go through, you know, there is a thing called GDS factory, even independent of eFabless. You can go through the entire exercise where you write the top level code in actually Python. And then there is this open lane, open something, then there is a thing called actually K-layout. You can do even actually silicon photonics design, there are examples of that. I mean, the self-learning right now is so easily accessible, right? And so just to say one more thing more, so what I am doing for the last 2-3 years, I am choosing to be advisors for companies like this, which are forward-looking. So one is this, another one is an Indian actually company called 10Xer. They are, like Renesas is their actually anchor client. And Renesas, when they do chips, instead, in the old days, they used to send electronic boards to their existing actually clients and say, we have built this new chip, actually try it out. Instead of that, now what they say is, we have built this new chip, you have this much time for free to get access through actually 10Xer online. So imagine if it is a DC motor chip, then it'll be, actually the motor will be attached to it and you can see it moving and you can measure RPMs and all that virtually, right? So a lot of such things are happening which are innovative in a way, and if we integrate all these things in our educational actually programs, then a lot of things will happen. And this is already happening. We just have to be aware. I mean, it's not like we have to all do it, right? All have to be just aware. Other thing I can share is sort of Dhirubhai Ambani Institute in Gandhinagar. From this last fall 23, they have already started BTech course in semiconductor engineering. And my guess is that all actually colleges will do a year or two later. So now we'll have a degree not in electrical engineering, mechanical engineering, in semiconductor engineering. And at least they'll have all the background, right? And then, yeah, 6-month training, 12-month training, this and that. And then you'll have even like actually diploma courses like that. Right? So anyway, it's good that I got this opportunity to meet all of you. And thanks for at least bringing this on your own to the team.
Ladies and gentlemen, good evening. My name is Praneet Shukla, and I'm part of the Maratha Chamber of Commerce. I'd like to start by thanking each and every one of you for joining us for this event and helping us make this a grand success. I'd also like to acknowledge the efforts that have gone in by the SEDG and MCCIA team. And please, thank you. I'd also like to thank our compare for today's event, Ms. Anaga Natekar. She's done a fabulous job. A round of applause for her as well, please. I'm sure there was a lot of learning that we, did today, and I'm sure a lot of takeaways for us to take and learn from. So with this, I declare this conference closed, and thank you. Please do join us for a cup of tea outside.
We can't close the conference without acknowledging two key people. Mr. Prashant Joglekar, please. The wonderful arrangement what we have seen today is all credit to Prashant ji and Pranit Shukla to coordinate with. Yeah. Ajit ji, yeah. So these two gentlemen have really worked very hard to organize all this setup, all the lunch arrangement, everything, plus coordinating with ministry, coordinating with speakers. All credit goes to these two gentlemen. So please have a cup of tea which is there outside the conference. Thank you very much.